All right, so let's talk about scaling. Now we're going to start by looking at kubectl get nodes. Remember, we have 3 servers that are willing to do work for our application. If we look at what our deployments are like, if we say kubectl get pods, we can see that currently we have 1 front-end container and 1 back-end container. We can see by the counts. We get a little bit more information with the -o wide parameter, and we can see where it's running. So the back-end container is running on VMSS0, which is the first one, and the front-end container is running on VMSS0 as well. So our understanding right now is the first, the second, and third virtual machines aren't completely unused, right? We have a 3-cluster AKS and we're only using the first server. So scaling on AKS, it's interesting because there's 2 ways to do it. One is we can simply increase the number of pods. And so we can say kubectl scale replicas equals, and let's say I want to make it 3. Actually, I'm going to cheat a little bit. Let's say I want to make it 3. I can say kubectl scale replicas 3, and then I name the deployment that I want to scale. And so in this case, it's the Azure Vote Front deployment, which is this one. And when I run that, boom, it says scaled. And if I go back to get pods in the wide view, we can see that it's running. There's now 4 entries, 1 for back and 3 for front. And what's interesting is that now we get 1 deployed into the second VM and 1 deployed into the third VM. So now we're actually seeing as we're increasing the resources. Now, I should mention that the way that containers work is you specify in the YAML file the amount of resources that it needs. So if I go back into Azure Vote.yaml and we skip over this first section, we go into the Azure Vote Front deployment. Then we can see here that it's requesting a certain amount of CPU and a certain amount of memory. In this case, it's 128 megabytes. And it has a limit in terms of the maximum, so the minimum and maximum that it needs. So remember, these are DS2 servers. We can quickly look it up, Azure VM DS2. So the DS2 server has 7 gigabytes of memory. And so if we're only requesting a maximum of 256 megabits for a container, then that can contain 28 containers on a single server. So if I exit out of this, I should be able to scale this out to 28 and not even run out of, and that's just a single server. Prepare for the craziness. But we can see that this is being scaled between 210, 210, 210, etc. And the containers, like I said, we know how much resources it requires, and it can be deployed across all these servers. Now, it's a bit chaotic, obviously, but scaling this down is fairly straightforward as well. So if we said, okay, well, 28 is obviously too much, we can scale down to 1. Then we are back. It's going to terminate all of these things, but we're back to just having the front end and the back end running. Now, that's only one way to scale. So we haven't even, by scaling the pods, we are not increasing the costs. We're using the existing servers that we're paying for, and we're just getting more out of them because each container has a limit in terms of how much resources it can take. If we needed to scale the servers themselves, remember, we were here in the portal. It takes me back to here, but we can go under node pools, and of course we can manually scale the number of nodes if we ever need to do that. But there is a thing called the autoscaler. Let me just check. Now we're back to just the 2 pods running. So we could use the autoscaler in order to get this number of servers to increase when it's required. So let's say we were to go beyond 28 times 3, we were to go beyond 70, 80 containers, then we're going to need more servers. Well, if we were to enable the autoscaler, then we're going to be able to have more servers created when more servers are required. And so that you can set the number of CPU, minimum, maximum, etc., and it can deploy or scale back on those servers.